Hi, I'm Dennis Mistry. I'm the Clinical Product Manager for the hearing aid fitting products here at Interacoustics. I'm here at the Interacoustics headquarters in Denmark, and I want to show you this wave installation that we have here, which showcases the 5 different configurations that we have of the Affinity Compact. At each of the stations, I'll highlight to you one of the important features which can help to make your hearing aid fittings easier. So here we have the Affinity Compact in its clean desk configuration. Here you can see that the unit is mounted to the bottom of the table. We call it the clean desk configuration because we've mounted the hardware and brackets for transducers to the bottom of the table here. And it can be configured for both audiometry and REM setups. Now the feature that I want to talk to you about when we're at this station is the ambient noise feature. In the development process, when we were investigating what we wanted to include in the product and what was a necessity to make the product future-proofed, we realised that there were many patients that had complaints that were linked to a poorer audiometry session from the start. And all good hearing aid fittings begin with good audiometry. So we tried to create a solution for this, and that is our ambient noise feature that we see here. So the ambient noise feature is this section that you see here on the left of the screen. Let's just take a look at the software. And what you'll see are a live recording or a live indication of the noise levels in the room, which are being provided by this dedicated microphone that we see at the top here. So the levels that we see and the bars that we've set here are standard based, which you can then choose and configure for different transducers as well, should you wish to. And if the level is below the indicator or the bar, as you'll see here at 125 Hertz, then it will be fine and we're not working in elevated levels within the environment. If you look at these levels here, where they're slightly elevated at 500 and 1000 Hertz, the indicator will highlight yellow-orange, which means that when I'm testing at these frequencies, if I was to store a threshold and this noise level was to persist, then maybe it discredits the quality of that audiometry point. So it may make me want to rethink and re-edit that ahead of storing that point again. So, yep, this Affinity Compact ambient noise feature helps us to get real good quality audiograms when we're going ahead in our fittings. So here we are at our second configuration of the Affinity Compact. And this configuration is the desk-based Affinity Compact, which has a outward-facing speaker, so it can sit in this position. This device can be configured to perform audiometry and relay measurement. And what I want to show you here at this configuration is actually that we followed a trend in the development phase of what the hearing aid industry was doing. And one of the main trends that they're following is to increase the bandwidth, to amplify up to higher frequencies. And this is beneficial for a few reasons. So first of all, it gives a better naturalness perception. Second to that, it gives a better music appreciation. And finally, higher frequency listening leads to better ability of directionalization. So if you are in a space, to localize where the sound is coming from. We felt that this is a trend that we needed to capture in our hardware, both to make it more functional and also future-proof. And to do this, we've improved the microphones in our REM headset and also the speaker technology for the forward-facing REM speaker here. So we've got better microphones to measure up into higher frequencies and also better loudspeakers that allow us to stimulate into these higher frequencies as well. So let's see how this translates into our software. So here we can see our measurement, one that I performed earlier, and we have a nice measurement response all the way across the frequency domain. We can see here that we're measuring above 8 kHz and into 12.5 kHz. And it's not only this frequency increase that we're seeing an improvement for, but actually these slightly lower high frequencies that we see here have a better measurement response and sustainability and preservation of the actual measurement signal, because the measurement microphone does measure into these higher frequencies. This is a really important point, especially considering the measurement reliability, comparing the system to systems that do not measure into these higher frequencies as well. So here we are in our third configuration. And the hardware configuration here is exactly the same as what I showed you before on the desk-mounted configuration. However, the difference is that we've mounted this to the wall. So this system here can do audiometry and/or relay measurements. In this configuration, I'd like to show you the delta values feature, which is something that we've developed to help you to match hearing aids to target when you're doing your fine-tuning and fittings. The delta values feature helps you to compare your measurement curve in relation to your target, and actually the software is working out the difference for you between that measurement curve and the target. So you know exactly how much you need to alter your hearing aid software by to get a target match. So here at 1 kilohertz, we can see that this is negative 1 decibel, meaning that the measurement curve is below the target by 1 decibel. For the values that show positive values of the delta value, then it means that the measurement is above target, and a absolute target match is where you hit a 0 dB level. Of course, a target match and a quicker location of the target match is your starting point to your fitting, and once you've attained this, then you can go ahead and fit the hearing aid and counsel the patient further with extra fine-tuning. So here we are in the 4th configuration of the Affinity Compact, and this is the open test box Affinity Compact. This device allows you to perform audiometry, relay measurements, and coupler fitting of hearing aids. The feature that I want to describe to you or explain at this station is called Listen To. Now, when you're fitting hearing aids and you're trying to understand the patient's feedback along with what you can see on the test screen, it can sometimes be difficult to fully understand what the patient's trying to explain or convey. This feature allows you to use the monitor headset here and listen directly into the measurement microphone. This could be either on-ear measurements or in the coupler measurements, and this will allow you to use that subjective feedback better to get to the desired hearing aid fitting quicker. It also has a second application, and this is where you can use this monitor headset and give this to the patient's support. And this helps to involve them in the hearing aid fitting process much more in depth, and as well explain and perform that counselling in a much better way, especially when you're trying to explain the benefits of different hearing aids. So here we are in the 5th and final configuration of Affinity Compact, and this is the full and complete version of the Affinity Compact. This allows you to configure it to perform audiometry, relay measurement, and hearing instrument testing, and you can also perform coupler fitting of hearing aids in the test box. At this station, I want to show you the hearing aid transition feature, and this is something that we discovered or we created whilst doing the development phase of the Affinity Compact. And it supports the scenario where you have a patient that's attending your clinic for the first time, but they already have hearing aids and yet you've never seen them before. So this tool and this feature can allow you to upgrade your patient to newer technology, but actually record and copy the audibility settings that they like from their existing hearing aid. This is really nice also when trying to upgrade the patient, but also when trying to keep the settings they like and also to understand proprietary fitting algorithms so that we can keep the momentum with their fitting rehabilitation. So here we have the measurement that I've just made a moment ago on their existing hearing aid. So this is the hearing aid here. We can use this measurement to then compare of its actual performance against what a standard fitting algorithm would perform. And again, remember, this is the sound that the patient likes. This is what they're used to. This is their preference for audibility. We'll now change the hearing aid in the box to the new hearing aid that we're going to fit for the patient. And now we can go ahead and make the measurement on the new hearing aid to then fit it against the existing and previous hearing aids output. So we're keeping the audibility that they like, yet we're upgrading them to the new technology of the newer device. So here we have an example of the hearing aid that's been matched to the previous hearing aid's audibility, and we can also on a second program match the hearing aid to a third-party fitting algorithm like NAL or DSL, and this will give them the best of both worlds in, first of all, the audibility that they prefer, but on their second program the correct audibility that will help them to rehabilitate and hear speech and language better. Thank you for watching. I've now explained the 5 important features of the Affinity Compact, which include ambient noise, high-frequency relay measurements, delta values, listen to feature, and hearing aid transition, which are all really important in your adult rehabilitation and hearing aid fittings on both adults or pediatrics going forward. Should you require more information about the Affinity Compact, please visit interacoustics.com, else reach out to your local Interacoustics representative.